Okay, lesson 2.8 is explaining multiplication and division related facts. The big idea is that there's this property called the multiplication property of equality, and it explains how multiplication and division facts are related to one another and has helped us solve problems that we can get into this form. Now you might need to do some other stuff, some other properties to get it into this form, and there are some other things explained in here other than this property that'll help you get it to here. All right, the homework is to, after you're done listening to this presentation, to reread the handout. If there's anything unclear, then go to that particular part of the lesson in the book and take notes just on that particular part. Okay? So go to the section, take notes. If it's not unclear, if you understand what's going on after the presentation, then you would do 1 through 35 odd. Okay, let's start with addition and subtraction fact triangles. We had those in 2.7. It basically says you could set up an algebraic fact triangle with h plus 3 equals 5, 3 plus h equals 5, and the other two facts as well. You can do it similarly in multiplication and division fact triangles, but you're going to see in this presentation there's sometimes when this fact triangle won't work with certain numbers, and that's what we're going to talk about. So let's first start with this multiplication property of equality. It says I've got some real numbers a, b, and c, and let's say a is equal to b. Okay, and a could be like a whole expression equal to b, another whole expression. Okay, if I do the same thing to the left side that I do to the right side, and that's like I multiply both sides by the same thing, I've maintained equality. You've done that before, right? I have a number. Okay, and I multiply it by another number. As long as I put the same number on both sides, I've kept things equal. Well, we'll come back to this example in a second. Because I also have the division property of equality. It says, hey, I got two things, a number equal to another number, or an expression equal to a number, which is a lot more likely. And if I do the same division problem to both sides, I have again maintained equality. Well, let's look at the examples. I've got a really simple example here because I want you to focus on the property, not the math. 5x equals 35. Of course the answer is 7. We all know the answer is 7. But let's figure out how this property helps us get there. Well, if I've got 5x equals 35 and I want to get rid of this 5 and get down to x, well, I could multiply by 1/5. Yeah? Because 5 times 1/5, hey, those guys are reciprocals of each other, which we also call multiplicative inverses. And that gives me 5 over 5 times x, right? And 5 over 5 is 1. Hey, yay, I got the 5 to go away. Well, if I do it to this left-hand side, I got to do the same thing to the right-hand side. So 35 times that same 1/5 that I chose over here to get rid of the 5, I've got to use over here. 35 times 1/5, 35 over 5, I'm down to 7. Okay, so I did the same thing on both sides to solve for x. I chose the 1/5 because it would make the 5 go away, because they're reciprocals. Same thing down here with division. I have the exact same equation, but instead of multiplying by 1/5, I could say, hey, I'm going to divide by 5. So as long as I divide both sides by 5, I make the 5 go away, and I'm back down to x equals 7. All right, then let's talk about the related facts property. Well, what I was saying a little while ago is this doesn't work for every single number. See right here? It works for non-zero real numbers. That means it doesn't work for 0. And we're going to talk in a couple slides about why it doesn't work for 0. But for everybody but 0, all the negatives, all the positives, all the integers of any kind, all the decimals, all the fractions, everybody but 0, this guy works. Okay? All right. Before we get into 0, I just want to give you this whole summary slide because this is in my book and not in your book, and I thought it was a handy-dandy summary of a whole bunch of stuff and how they work in multiplication and how they work in addition. But the one that we're going to talk about right now is this guy right here, the related facts property for multiplication and the related facts property for addition. And see right here, they say with this one where they're using x, y, and z for the 3 facts, okay, or for the 3 numbers, x, y, and z cannot be 0 in multiplication. None of them can be 0. But over here, okay, a, b, and c, any of those guys could be 0. They don't put any restrictions on it. Okay, so let's talk about this whole 0 predicament. So I got a number, a, any number. Okay? And I multiply a times 0. Yeah, that's the same thing as multiplying 0 times a. And both times I'll get 0, whether I put the a first or the 0 first. Okay? Okay, so given that, and we all agree with that, how does that hook into this related facts property? Well, we're going to see 0 does some funky stuff where you really can't do this because you can't divide by 0. Which also means if you can't divide by 0, you can't have 0 in a denominator because a fraction is a division problem. Okay, let's talk about this in a little more detail. Here's part 1, and we're going to have part 2. Part 1 says, what if I put 0 in here as the product, up here at the top? Well, that means a times 0. Cool, that gives me 0. It works when I'm going up. 0 times a. Yeah, that works both directions going up. No kidding. Okay. How about if I go down? I have 0, and I divide by a. Actually, that works. 0 divided by 7. If you can picture that as a fraction, that's 0 over 7. That's 0. That works. Coming this way? That works. Here's the guy that doesn't work. 0 divided by 0 equals a. That's not working because a is any real number. 0 divided by 0 doesn't give me a real number. It doesn't give me 5 and 7 and 11 and, negative 22. Those are all real numbers, okay? So that guy doesn't work. Okay, what if I put 0 down here instead? Instead of putting it in the product, let me put it in one of the factors. All right, b times 0. That doesn't give me a real number. Yeah, and 0 times b, that doesn't give me a real number, obviously. Oh man, that didn't work. All right. How about this way? A divided by 0 gives me, I divided by 0 does not give me a real number. Like 5 divided by 0 does not give me a number. So this guy doesn't work in any direction. Okay? So you can't divide by 0, whether it's up here or down here. Okay? All right, so what does 0 do or not do? Well, let's look at this equation. 0 times a number equals 0. Hey, all numbers work in this situation with 0. What if I put like just 0 here and I have a number over here? Nothing's working there. Okay, so this works if it gives me 0, but it won't give me a real number. All right, well, how about this one? 13 times something gives me 0. That works, but only for 0. So these are the three possibilities. A times b equals c. If a and c are 0, anything works for b. A times b equals c. Nothing's working there. Okay? And then a times b equals 0. I can put any number in for a. As long as I put 0 in for b, I'll get 0. Okay, so that guy says, you know what this is about? This is about something called the zero product property, which means that if I have two numbers, a and b, okay, and the result of them is 0, this or that, then a can be 0, or b can be 0, or they could both be 0. All right, now, that was a couple funny things that 0 does. 0 cannot be divided, and 0, when it's multiplied, always results in 0. But 1 also has some funny things that it does. 1 does something called this multiplicative identity property. You sound really smart when you say that. A times 1 is the same thing as 1 times a, and they both equal a. Whether I write the a first or I commute it and I write the a second, I still have a. And that means a keeps its identity when it's multiplied by 1. Multiplicative identity. I kept my identity even though I got multiplied. Okay? So this actually works even for 0. It works for like 5. 5 times 1 equals 1 times 5 equals 5. But it also works for 0. Hey, cool. 0 times 1, 1 times 0, works for 0. Okay? So 1 does it for every number, including 0. Now, 1 also has another cool thing it does. Besides any number multiplied by 1 is that number, which is the multiplicative identity property, we also have the multiplicative inverse property. You also sound really smart when you say this one. So if any real number, a, but a does not equal 0, that's important. We'll come back to talk about that in a second. But let's just say what happens. A times 1 over a, all right? Or I commute it around, 1 over a times a. In either case, I'm going to get 1. Because in this one, I'm going to get a over a. And this one, I'm going to get a over a, and that's 1. Okay? So if a is multiplied by its inverse, the product is 1. Now I said I'd come back to why this can't be 0. Because I can't have 0 in a denominator. Right? I cannot have 0. I can have 0 over here, but I can't have 0 here because of what we talked about a little while ago. Okay? Alrighty. So the multiplicative inverse is also known as the reciprocal, but it is not. Did I mention it is not the number flipped over? Okay? So the multiplicative inverse property says a times 1 over a is equal to 1 over a times a equals 1. And the reason this is helpful for you is, let's say you have an equation. It says something like 3/4 x equals 12. And I want to get rid of the 3/4 in front of the x. I can multiply both sides by 4/3. And the 3/4 times 4/3 is going to be 12 over 12. And that coefficient in front of the x goes away. Now remember, I've got to do the same thing to the right side. So don't forget to do that. Multiply both sides by 4/3. Okay? Now, if you don't have any questions, go on and review the handout. Then when either at home or in class, whenever I assign it for you, you can do 1 through 35 odd. If you're a little bit confused, and you might be because I went through this pretty quickly, you can read the section of the book that goes to whatever section you need to some assistance on. And take notes. All right, talk to you later.